So subsetting a list is a little bit different because you can use the double bracket or the $ operator. You can also use the single bracket operator. So here I've got a list. The first element is a named element called foo. It's an index and it's a sequence 1 through 4. And the second element is named bar and it's the number 0.6. So this is a list of 2 elements in it. I can extract the first element using the single square bracket, and I get remember the single square bracket always returns an element that's the same class as the original. So if X is a list, then X bracket 1 is going to be a list too. So what I get back is a list that has an element called foo, which is a sequence 1 through 4. Now if I use the double bracket, then if I say X double bracket 1, what I get back is just a sequence 1 through 4. So the difference here is that in the first example, I got a list that contained the sequence 1 through 4, and in the second example, I got just the sequence. That's the difference between the single bracket and the double bracket operator. In the next example here, I'm using the $, so I'm saying X $bar, and what that means is that gives me the element that is associated with the name bar. So in that case, it's a single number 0.6. I can also use the double bracket operator and pass it a string. So X double bracket quote bar is the same as doing X $bar, and it just gives me 0.6. If I use the single bracket with the name, I can say X bracket quote bar. That gives me a list with the element bar in it. So remember, because the single bracket always returns a list if I'm going to subset a list. So the nice thing about being able to subset an element using its name is that you don't have to remember where it is in the list. So if I couldn't remember whether bar was the first element or was the second element, I don't have to remember where it is in order to use the numeric index. I can just use its name, and then then it will automatically extract that element from the list. If you want to extract multiple elements of a list, then you need to use the single bracket operator. So for example, if I want the first and the third element here, which is the foo and the baz element, I can pass a vector 1, 3, the numeric vector 1, 3 to X using the single bracket operator, and that returns to me a list with the elements foo and the elements baz. So that's how I extract multiple elements of a list. You cannot use the double bracket or the $ operators when you want to extract multiple elements of a list. The nice thing about the double bracket operator, which is different from the $, is that you can use the double bracket operator to index a list where the index itself was computed. So notice that when I used the $sign before, I actually typed out the word bar. I had to type out the name of the object. But sometimes the name of the element. But sometimes the name of the element is actually the result of some computation. So for example, here I've got a list with 3 elements, foo, bar, and baz, and then I create a variable called name, which is actually the string foo. So if I use the double bracket operator on this variable here, notice that there's no element in the list that has the name in it, but there is an element of the list that has the name foo in it. So now when I pass this variable called name into the double bracket operator, it returns me the element that was associated with foo, because that's what the value of the name variable is. So if I compute the index that I want to use, then I have to use the double bracket operator. If I use the $, then it's going to literally look for an element of the list that has the word name associated with it, and that of course doesn't exist in this list. So to use the $, I need to use a literal symbol. Now, the double bracket operator can take an integer sequence rather than a single number. And the way you can think of this is that it kind of recurses into the list. So if you look at this current list I've got here, with the first element A is another list which has elements 10, 12, and 14. So suppose I wanted to extract the number 14. Well, that's really the third element of the first element, right? So it's the third element of the list, which happens to be the first element of the other list. And so I can extract the 1, 3 element from it by passing the vector 1, 3 to it, to the X list using the double bracket operator. And that's equivalent to kind of doing this double subsetting of 1 and 3. I can also extract the first element of the second element by passing the integer vector 2, 1 to get 3.14. So partial matching is a handy tool which can often save you a lot of typing at the command line. It's not particularly useful when you're writing out programs and functions, but it's very useful when you're kind of working at the command line, typing things as fast as you can. So the idea with partial matching is that it works with the double bracket and the dollar sign operator. So suppose I have a list X which has an element in it called aardvark, which is a sequence 1 through 5. And suppose typing out the word aardvark every single time is a bit of a pain. So I'm just going to type the word A. Well, the way the dollar sign works by default is that it looks for a name in this list that matches the letter A. In this case, there's only one element, and so you get the word aardvark, and it gives me the object associated with aardvark, which is the sequence 1 through 5. So if I use the double bracket operator, things are a little bit different. So what the double bracket operator expects is that that the name that you pass it is going to be an exact match for one of the names in the list. So by default, the double bracket operator doesn't do partial matching like the dollar sign does. So now when I pass X double bracket A, what happens is I get null back because there's no element of the list that has the name A. But there's a second argument that you can pass to the double bracket operator, which is the exact argument. And if you specify that exact equals false, and then when I pass it X double bracket A, it gives me the sequence 1 through 5, because that's the one that matches the letter A the closest. The last thing I want to talk about is removing missing values, or NA values, from an object. This is a very common operation in data analysis because most realistic data have lots of missing values. And so the way you can do this for either a vector or a matrix or a data frame is you want to create a logical vector which tells you where the NAs are, and so that you can remove them by subsetting. So here I've got a vector X. This is a very simple example, which has the numbers 1, 2, and 4, and 5, but then there are missing elements NA in the 3rd position and in the 5th position. So what I want to do is I want to get a vector back that's just 1, 2, 4, 5, the non-missing values, and I want to strip out the missing values so I can maybe do some computation. So first thing I do is I use the is.na function to go through the vector and tell me which elements are NA, and I create a new vector which I call bad here. So bad is going to be a logical vector which is true if the element is missing and false if it's not missing. So even though I haven't printed it here, the bad vector is going to be a logical vector that has false, false, true, false, true, false, right? Because the 3rd and the 5th elements are missing. So now that tells me which ones are missing, but actually I don't want the ones that are missing. I want the ones that are non-missing. So I need to take the kind of the opposite of bad, which I can use with the bang operator or exclamation point. So now I take X single bracket bang bad, and that gives me the good elements, which are 1, 2, 4, and 5. So what if there are multiple vectors or multiple objects, and you want to take, and each one has kind of missing values in slightly different places, and you want to take the subset of all the objects that have no missing values, right? So here I created a vector called X, which is 1, 2, 4, and 5, and missing values scattered about, and then Y is a character vector with also some missing values in it. So I can use the complete cases function on both vectors, which will give me a vector that tells me which of the two different vectors, which positions are there that have both elements non-missing. So you can see the first two are both non-missing. I got 1, 2 in the first one, and A, B in the second one. The 3rd one's missing. The 4th one is non-missing. The 5th one is missing, and the 6th one is non-missing. So for both vectors X and Y, I want the 1st, the 2nd, the 4th, and the 6th elements. So now when I subset X, I get the good elements of that, and when I subset Y, I also get the good elements of that. So that's how I can look at multiple objects and kind of subset all the missing values out to get the good elements. You can also remove. You can also use complete cases to remove missing values from data frames. So here I've got a simple data frame where I'm showing the first 6 rows. As you can see, there are 6 columns to this data frame, so there's 6 variables. And there's some missing values in the ozone variable, and there's some missing values in the solar.r variable. And so all I want is are the rows of the data frame where all the values are non-missing, right? So in this simple example, the rows that I want are rows 1 through 4. So I can use complete cases on the air quality data frame, and I create a logical vector that I call good here. So the logical vector here tells me which rows are complete. And then when I subset out the air quality matrix, and I take out the first couple rows, you can see that none of the rows have any missing values in them. So that's subsetting out missing values. And complete cases is a very handy function, which is when you have multiple sets of vectors or large data frames where you want to subset out all the missing values.